Snapshot IDs are 19-digit numbers. Nobody remembers them, nobody puts them in runbooks, nobody shares them in a Slack message and expects anyone to know what they mean. Tags solve that, and branches let you do something even more powerful. Write to a copy of your table without touching production data at all. Think of it exactly like Git. Tags are immutable bookmarks, branches are writable lines of development, your data, your table, same concept. Before we write any SQL, let me explain the model clearly. A tag is an immutable named pointer to a specific snapshot. You create it, it never moves. It also protects that snapshot from expiration, meaning even if you run a cleanup job, that snapshot stays alive for as long as the tag exists. A branch is a mutable named pointer. You can write to it, inserts, updates, deletes, they all go to the branch and the main table stays completely untouched. When your experiment is done, you can promote the branch to main or just drop it and walk away with zero impact. Let's create a tag first. We are tagging the current snapshot before doing anything else, so we have a permanent named bookmark. Let's run this and wait for result. That's it. The current snapshot now has a human-readable name and is protected from expiration for 90 days. Even if a cleanup job runs tomorrow, this snapshot survives. Now watch how clean the time travel query becomes. Let's run this and wait for results. Same 5 rows we have been seeing, but now the query reads like a sentence. Pre-Q2 migration. Anyone on the team can read that and understand exactly what moment this is pointing to. No 19-digit numbers in your runbook. Now let's create a branch. We are going to experiment on a copy of the table without touching the main data at all. Let's run this and wait for results. Branch created. At this moment, it is pointing to the same snapshot as main. They share the same data, nothing has diverged yet. Now we write to the branch. This requires Spark, not the SQL editor directly, but the concept is what matters here. Let's run this and wait for results. That insert goes to the branch only. Main is completely untouched. If you then read from the main, let's run this and wait for results again. Order 99 is not there. Main has no idea the experiment is happening. Now, if you read from the branch, let's run this and wait for results. Order 99 appears. The experiment is isolated to its own branch. This is how you run pipeline tests, data quality checks, or migrations without any risk to production. If the experiment worked and you want to promote it to main, you use fast forward. Let's run this and wait for results. This moves the main pointer forward to where the branch currently sits. No data is copied, no rewrite happens, it is just a pointer change, same as rollback. When you are done with the branch or tag, clean them up. Let's run these and wait for results. The snapshots they were pointing to may still exist temporarily, but the named references are gone. Once the snapshot has no references protecting it, it becomes eligible for expiration cleanup. Finally, let's look at the refs table now that we have created named references. Let's run this and wait for results. 1 row. Just the main branch remaining. The tag and the experiment branch have been dropped, so they no longer appear here. This is exactly what you want to see after a cleanup. The refs table shows only active references, drop a branch or a tag, and it disappears from here immediately. Tags give your snapshots human-readable names. Branches give your data a safe space to evolve without risk. Together, they take Iceberg from a reliable storage format to something that works like a proper version-controlled system for your data. Thank you.